Okay, good evening, everyone. So, today we are diving into an exciting demonstration that combines the power of advanced AI language models with real time web search capabilities. The code we will be walking through showcases how to leverage multiple cutting edge technologies like LangChain, Cohere, and SERP API with a glimpse into Google's API. Google's Palm API. Okay, so our goal is to see how these tools can come together to create an intelligent agent that not only answers questions but also actively searches the web to provide more accurate and up-to-date information when needed. So let's think about it for a second. We live in a time when information is more accessible than ever. But there are still challenges when it comes to fact checking and obtaining real time data. By using Cohere, we tap into a powerful language models for natural language understanding and generations. And with SERP API, we give this model the ability to search the web just like we do on Google. This opens up a whole new level of intelligent querying where the agent isn't limited by pre-trained data but can access real-time knowledge to provide more comprehensive answers. So, over the last few minutes, we will walk through the code step by step and we will explain how each piece works. From setting up the model to initializing the tools and agents that work behind the scenes. Whether you are familiar with the language models or this is your first time hearing about how these system works, this walkthrough will give you a clear understanding of how AI and search can be integrated to mark well-informed decision. So, without further delay, let's get started and see the code in action. So, this is our code for adding memory. Okay. So here what we'll do, we will install some libraries over here. Okay, what we are doing in this code? So we are integrating the LangChain with Google's Palm API. Okay, and we are using memory to track the conversations. So for that, we will need some libraries. So these are some of the libraries we need to install. Okay, so this is LangChain. This for installing LangChain, we will need pip install LangChain, right? And this LangChain is a framework to build applications with LLM. And Cohere. Cohere is a library for text generation. And this tick token is a library which helps manage tokenization in language models. Okay. Then there is pip install Google Generative AI. Yes. So here it will generate the Google's Palm API key for text generation. Okay, we'll use this for text generation. Google Palm's API key. Okay. From now we will import some libraries and setting up the Google's Palm LLM. Okay. For that, we are importing necessary classes and modules. These are the necessary classes and modules here for embedding the generation and using the Google Palm for LLM tasks. Okay. So what we are doing here, we are importing some of the modules here. From LangChain, we are importing embedding and importing the Google Palm embeddings. Okay. From LangChain.llm, we are importing Google Palm. And from import, we are importing? We are importing Google.generative AI. Okay. So what it will do? We are initializing our LLM model and we are saying Google Palm. Herein we are writing our Google API key. Okay, that will be a secret key. So it is written as XXX. Okay. The Google Palm model using API key will allow us to integrate with Google's generative AI services. Okay. So after that, what we are doing? We are doing predictions. LLM.predict. Here, LLM.predict will predict the method of Google Palm models to generate the responses to a specific input. Whatever the input we are uploading, that will be updated. That will be represent as an output here. See here, LLM.predict. Here we are writing in the codes, and that is what is generating here. Okay. So apart from that, we are again generating LLM.predict, and .predict is predicting the whatever it is generating the responses to a specific inputs. Okay. So this is it. Here we are generating we are doing some of the predictions. Okay. And some of the words are, this shows how LLM, see here, here, what is the capital of France? And it is showing Paris. Okay, what is the secret word? It is showing banana. So this shows how LLM can handle memory-based queries and fact-based. Yes, this is having some memory also. So it is generating from that. Then in the conversation buffer memory, what it is showing? These lines import conversation chain. Okay, and conversation buffer memory. These two classes allowing us to maintain a conversation with the LLM and remember the previous inputs. Okay. And also what it is doing? It is, see this, from langchain.chains, we are importing conversation chain, and from langchain.memory, we are importing conversation buffer memory. Okay. After that, we are importing memory is equals to conversation buffer memory, and conversation is equals to conversation chain. That is, we are initializing in it as LLM is equals to LLM, memory is equals to memory. Here is the memory that is equals to memory, and verbose is equals to true. Okay. So this initializing the memory that stores all the previous exchanges. Whatever the previous exchanges there, it is now we are initializing the memory in it. Okay. And we are simulating a conversation history from behind. Okay. And after that, in the conversation chain, we are creating with LLM and memory. This enables the LLM to hold context from previous conversations. Okay. So conversation.predict will what it will do? It will hold the previous memory, and whatever the previous memory will have information, it will gather all the information from it, and then it will generate the output according to that previous memory. Okay. See, it is generating, it is taking all the previous it is taking all the previous memory, and then it is generating the output. Hi, yes, I remember the secret word is cat. Okay. And here the conversation.predict, here we are importing what is the capital of France? Earlier in the past, we have questioned this, and it was generated there as Paris. Now let's see, it is giving the output as Paris. Paris is the capital of France. So it is keeping the conversation from the previous history. Okay. Then here print memory.buffer. So whatever the memory buffer, it will do? It will generate, it will show the history of the conversation. What was the history? Previous history, that whatever the chat we were having in the past, that it will be generating. Okay. So hi, remember the secret word is cat. And AI generated as hi, yes, I remember the secret word is cat. Human has returned, what is the capital of France? Then AI has returned, Paris is the capital of France. So again, human has returned, what is the secret word? Secret word is cat. So it has been generated. Okay. So after that, this memory load memory variables. It will again generate all the variables in it. Okay. And this manually saving content, what we are doing, this memory dot save content will save a specific question answers. Okay. For example, here it is written, what is the capital of England? And we are specifically giving the output also as London. Okay, so here it will take it as a memory. It will take it into our memory, which will persist it into a future interaction. Whenever it will be asked, whenever any user will ask this question, it will then generate the output. Okay, see here. Again, we will write memory, a print memory dot buffer. It will generate here. What is the capital of England? We can see the output as London. Okay. So here in this chapter, in this code, we have understood about the memory. We can track the memory into it, and we can add the memory. We can purposefully add the memory into it also, and we can showcase it also afterwards. Okay. So the next thing is our iterative prompting. So in iterative prompting, what we are doing for that, we will require these libraries. So first look into it, what pip install Google Generative AI. So Google Generative AI will provide our access to the Google's Gen AI model like Palm. Okay, previously it was Palm. Here we are using Google Generative AI. Yes. Then there is LangChain. Earlier we have understood about LangChain. LangChain is a framework for interacting with large language models. Then PyPDF. PyPDF is a useful tool for handling the PDF operations or PDF files if needed in future. And Jupyter is a Jupyter notebook. It is a platform for running and displaying Python code. Yes. So this is it. We will installing all these libraries. After that, we will be importing Google.Generative AI as Palm. Okay. So we are importing all these libraries, packages, and configure it with an API key. See here, we are configuring it with an API key here. Okay. And this will allow us to interact with Google's LLM. Okay. And what we are doing then, os.get environment that can securely load our API key from the virtual environment, whatever the environment we are having. Then in this case, what we are writing, we are giving prompts. Okay. In the iterative prompting, what we are doing, we are using the iterative prompting. Like we are giving prompts and we are iteratively updating that prompts and what the changes these prompts are making to the output that we are seeing here. Okay. So here in this prompt, what is given? Here, give description of GRE sections. Okay. And in the prompts, we have written this. And in the model, in the completion, we have written palm.generate underscore text. Yes. And then in the models, which model we are using? We are using models that is text Bison 001. This model we are using, and the temperature is equal to 0.1. The temperature equals to 0.1 will ensures the generated text remains focused and fractal. Okay, and then we are writing print completion dot result. So whatever the result, it is showing here. Okay, see here, our prompt is giving us the output. Here we have asked for give description about GRE exam sections. So here in our output, we are getting the GRE general test schedule and this. So we are getting our output. Yes. Now what we are doing, we are updating our prompt, and we are saying give description of GRE exam sections in a tabular format. So in a tabular format, we are giving, and other apart from that, everything is same. Okay, the model is same, the temperature is same, the prompt we are changing, and that is it. Okay, now in the sections, it has been updated to see here the output. See, this is the output, and it is generated. It is getting generated in tabular format. Yes. Okay. Then apart from that, there are again different prompt here. See, what is written? Give description of GRE exam sections in a tabular format. Okay. But what is written? Columns to be added are section name, description, time limit, and score. These are the sections. Okay. And apart from that, the completion is equals to palm dot generate text. As we are using the palm API key, we are using this to generate our prompt. Okay, to generate our, and the model we are using is the same model. Okay, this is a model we can use, or we can use different model also from Hugging Face. Okay, this is a open source model. Okay, and temperature we are giving is 0.1. Okay, which will ensure the generated text remains focused and factual. Okay, and then we are printing it as completion dot result. So here what it is doing? It is segregating the section name, description, time limit, and score. Earlier it was giving only section, number of questions, and time limit. Yes, there was verbal reasoning, quantitative reasoning, and analytical writing. And the number of questions they have given, like 30, 30, and 30 questions. Sorry, 30, 30, and 2 questions, analytical writing. And time limit has given 30, 35 minutes, and 30 minutes. But here it has been giving the description of it, like measures your ability to understand and reason with written material. For verbal reasoning, for quantitative reasoning, it has been written measures your ability to learn, to reason with numbers and mathematical concepts. Yes, and the score is also given, which was not given earlier. There were only given the section, time limit, and score. Here the section, time limit, scores. Apart from this, description and score in detail has been given. Okay. So apart from this, see, in iterative prompting, as in how we will change the prompt, the output will change. Okay. See, here in the prompt, we are written, and the prompt should be written in a 3 quotes. This 3 quotes. This 3 quotes, 3 inverted commas. Okay. At the beginning of this and at the end of this. This will give our prompt. Okay. Give description of GRE exam sections in a tabular format, and this backward slash will give us a new line. Okay. The columns to be added are section name, description, time limit, and score. And then format everything as HTML. That can be used in website. Okay. Now format everything as an HTML. This place description in a division element. Okay. So here what is doing? What they are doing? What they are doing? We are directly embedding in a website. Okay. The description are placed inside this code. See this 2 codes. See this codes. Okay. This elements. Following the good website divisions, practices for separating the content into a container. This is the content, and this is the, see, this is the, in this we can write the headings. Okay. So this is for the HTML content. Okay. So we are giving a prompt to give the answer in an HTML format that can be used in our website. Okay. So we can do that also. So here for completion, we are using this palm.generate text, and for the models, we are using this Hugging Face model, open source model. We are using this text Python. Okay. Apart from this, different model we can use. Okay. Prompt is equals to prompt. This prompt is equals to this prompt only, and temperature we are giving 0.1. Okay. And this print completion dot result will give us the final result. So this is our output. See, this is our output. This has been generated, which can be loaded as a website, which we can load it as a website also. Updating a website or creating a website. Okay. And this from ipython.display will import display and HTML. What we are doing, display HTML completion.results. So what we are doing here, see here. Here the section name has been returned, description is returned, time limit and score has been given. So this ipython.display will generate our HTML, okay, within our Jupyter notebook using ipython.display module. Okay, this will allow the HTML table to render directly into the notebook, giving a preview of how it would look on a web page. Okay, so how it would look in the web page, we can see in this Python module itself by using this library ipython.display. Okay, so then we'll see, we have seen two codes. Okay, first we have seen the adding memory code. In the adding memory code, what we are doing, we are continuously adding something in our memory, and then what we have done, we have used this save memory, and we have used this buffer, memory.buffer, which will generate all the past memories in it. Okay, and we have used different thing also. 1 minute. We have used the conversation chain and conversation buffer memory to store the memory in it, past memory in it. Okay. So this was all about adding memory. Now we have seen the iterative prompting. In iterative prompting, what we have seen, we have first seen the, this is called the prompt engineering thing. Okay. We are continuously updating a prompt, and we are looking into what are the output, what has been changed in this, what has been improved in our prompts. Okay. And in the last, we have seen this HTML thing. Okay. And we have given a prompt to format everything as an HTML, and that can be used in a website. So it has been generated. We have used this model also, this open source model. Okay. So we have used different prompt engineering techniques for displaying our different outputs. Okay. And then by using this ipython.display library, we have seen how it will be looking at the HTML website. How it has been looked as in before actually creating a website, we can see how this output can be looked in our HTML website. Okay. Now is our third code, which is self-ask code. Okay. In the self-ask code, what is there? In this code, we are going to integrate with the LangChain, with Cohere LLM, this Cohere LLM, and Google's Palm API. And there is one more thing which is called as SERP API to create a search-driven LangChain model. Okay, this LangChain, pip install LangChain, what it will do? As we have seen in the previous two lectures, it will act as a framework for building an application with LLM. Okay, then there is pip install Cohere. So this Cohere is a platform for generating the text using the Cohere LLMs, Cohere's large language model. Okay. It is used for generating the text. And this pip install Google search results will is the library used for SERP API. Okay. Which performs real-time Google search through an API. It will search a real-time Google search. It will do a real-time Google search through an API. This API, SERP API. Okay, that we will see in this line of code. We will install these libraries. Then what we will do? We will import Google.generative AI as PALM. And what we will do? We will import our PALM API key, which is this, and SERP API key, which is this. Okay, you can use your own. It is publicly available and it is free of cost. Okay, for a limited database for a limited period. Okay, that we will see in this. From SERP API, we will importing Google search and Google search.serp API key. We are importing our API key here. Okay. Apart from that, what we are doing? What we are doing from langchain.llm, we are importing Cohere. What is Cohere? Cohere is a platform for generating the text. Okay, using the large language model. So this is this, and temperature, we are setting it as 0. Okay. And then we are from LangChain, we are importing SERP API wrappers. And from here, we will search what it will SERP API will do. What SERP API will do? SERP API will allow us to create the SERP API key to search real time in the Google. Okay. We can search anything in, but one more thing here is, it can ask follow-up questions also here, but here it has been given here 100 search per month is only allowed here. Okay. Then after that, what we are doing, we are importing OS, we are importing our agents, and we are initializing the agents and tools. So tool function will define what it will be defining. It will define a tool named intermediate answer. Okay, which will use in the search.run, Okay, this will initialize this. See, this tool will initialize the intermediate answer, and then it will be search.run. Okay, which will give us the intermediate answer to that question. Okay, description is useful for when you need to ask with search. Okay, so this is how it is. For example, if we'll ask the complex question, okay, if we'll initialize the agent and we will ask this question, the agent is initialized using the Cohere's LLM. Okay, and the defined tools, that is SERP API. This agent is of type self-ask. This is self-ask with search, meaning it can ask follow-up questions if necessary. If we need the follow-up question, it can ask necessary. Okay. And we are saying verbose is equals to true. What it means? It will ensure that agent provides detailed output during its processing steps, which is useful for debugging or tracking. Okay. Then what we are doing? We are running this. Finally running this agent, and we are asking the complex question here. Who is the president in US when superconductivity was discovered? Okay. So the agent will first consult the LLM Cohere here for an answer. And if the follow-up question will be generating, then enter new agent executor chain. Yes. Then the follow-up question was, when was the superconductivity discovered? So the intermediate answer was 1911. The follow-up question is, who was the US president in 1911? So the intermediate answer is William Howard Taft was elected the 27th president of the United States and then later became the third Chief Justice of United States, the only person to have served in both of these offices. Okay, so the final answer is William Howard Taft. Okay, the chain finished. So the answer is getting generated here. So this combination, what it will do, the agent will first consult with the LLM cohere, and if there is like follow-up question there, so it will use the SERP API key. It will use the SERP API to search for details online in the Google. Okay. Then this combination of LLM with the web search. LLM with the web search. With web search how? With the SERP API key. Okay. It will generate real-time Google search. It will do the real-time Google search from the website and creates a powerful tool for answering the fact-based queries that may require real-time or historical information. So this is it. So this is it for today. We have seen three Python codes. We have seen the added memory, iterative prompting, and self-ask. Okay. So there are some of the codes remaining that we will going to see in the next lecture. Okay. So this is it for today. Thank you for joining.